This video shows you how to conduct a rank-Biserial correlation in R. This correlation is used when you have dichotomous and ordinal data. Before you start, however, make sure that both your variables are not factors, but rather numeric. For the interpretation, you need to remember what category is represented by which number. For example, I want to correlate illness and motivation. Since motivation is ordinal, this is simply ordered in an ascending way. Illness is dichotomous and its absent is coded with 0 and its presence with 1. Calculation. Since the rank-Biserial correlation can be approximated by the Spearman-correlation, we can use the cor.test function in R. Simply enter your variables, no particular order is required. Furthermore, add method equals and in quotation marks Spearman. Additionally, in large samples it is important, because you have a higher chance of having ties, that you add the argument exact equals false, because the exact p-value cannot be calculated when you have said ties. Upon running this line you will get your results. Interpretation. You can see that the correlation is minus 0.098 with a p-value of 0.493, which is well above any alpha threshold. The null hypothesis can therefore not be rejected, which, like with every correlation, is no association. Therefore, we can observe no association between illness and motivation. But what if the p-value were low enough? This is a thought experiment to demonstrate in case of a low enough p-value how a rank-Biserial correlation would be interpreted. The rank-Biserial correlation tells us that if we increase the illness by 1, aka we go from absence 0 to presence 1, the motivation decreases. Put another way, ill patients have a lower motivation, or the other way around. In other words, illness is associated with less motivation, if the p-value were low enough, which it is not. Of course, you can also do an independent Wilcoxon test if you want to test illness or its absence for differences in motivation. Effect size. The effect size of the rank-Biserial correlation is the correlation coefficient itself, the absolute value to be precise. This means R can be classified with comparable studies or research field-specific thresholds. If neither exist, you can fall back to Cohen 92 A power primer and use the thresholds on page 157, 0.1, 0.3 and 0.5 for small, medium and large effect sizes. For my example, since I have no low enough p-value and strictly speaking no effect, I cannot quantify an effect size. Be aware though that some reviewers will still insist on effect size reporting and classification despite non-significance.